Welcome back, chemistry fans. Third time's the charm. I am hopeful that I get it correct this time and I don't make some silly mistakes. We'll see. All right, I'll jump right into it. What we're going to try and do is our warm up, and this one is for heat, dealing with two substances combining together to find their final temperature. We kind of did that in the laboratory with the cheesy poofs. Whenever we burn the cheesy poofs, we had water sitting on top of it, and that would then transfer the heat to the water so we could see how many calories there were. Well, in this one, we're going to transfer the heat to water, but we're not going to burn something. We're just going to transfer genuine heat from that system. So let's see if I am recording, which I am. That's what I forgot the first time. The second time, I just made a mathematical error. I am going to share my screen this time, and we will get started on solving this. Okay, so in this problem, just like we did for the calorie count, heat in is equal to negative heat out. But we don't really have a formula for that one, and it really doesn't apply to what we've got going up here until you realize that the heat in is going to the water and the heat out is coming from the metal. So what we'll do is we'll do mass of the water, specific heat of the water, times the change in temperature of the water is equal to the negative mass of the metal, the specific heat of the metal, and the change of temperature of the metal. Both of these, the change in temperature, that is T final minus T initial. So that is our same answer for TF. That's what we're looking for both the metal and the water, because if you put hot metal into the water, they're going to come to equilibrium. So that's what this scenario is. I have a piece of metal, and it's aluminum, and it's very, very, very hot. It's not a sun, but that's supposed to be the hot heat that's coming off of it. Now that looks just like a hairy piece of aluminum. But anyway, that is going into a cool drink of water, and the temperature is going to rise for the water, and the temperature is going to fall for the aluminum. So that's the scenario that we've got going here. So let's go ahead and start it. Water, what we need to understand, it has a unique property in that milliliters equal directly to grams. So that is 75 grams of water. The specific heat is not given in this problem. You can get that off your cheat sheet. It is a nice to know value, 4.18. The change in temperature, we don't know the final temperature. That's what we're solving for, but we do know its starting temperature is 23. Now we carry that negative through, and it's odd. It's not really negative 80. It's a negative symbol multiplied by 80 times the specific heat of the aluminum, which is given to us as 0.9. And then finally, again, the TF is what we're solving for. It starts out at negative 300. I'm sorry, it starts out at 325. We're going to subtract final minus the initial. Okay. So now we've gotten all of the data that we need out of the problem. So I'm scrolling down past it, and I'm going to simplify. Now I'm going to start multiplying 75 times 4.18. And we get 313.5, and that's TF minus 23 equals 80 times 0.9, and that is negative 72 times TF minus 325. All right, now we got to distribute so we can simplify and solve for that TF. So I'm going to distribute, and I got 313.5 TF minus, this is going to be a big number, 313.5 times 23. That's going to be a negative 7,210.5 equals negative 72 TF plus 325 times 72, and that's 23,400. All right, now we're going to bring like terms together. So this TF, I got 72 TF over here. I'm going to bring the 7,200.5 over to this 7,210.5. Those are going to cancel out. Those are going to cancel out. And we have now two terms where we had 4 before. So 313.5 plus 72 is 385.5 TF equals 23,400 plus 7,210.5 equals 30,610.5. All right, so now we have two terms. We need to get the TF by itself, so we will divide both sides by 385.5. Now, the hope is that this TF value is now going to be lower than 325. So 30,610.5 divided by 385.5, and you get 79.4 degrees Celsius. And yes, it did go down if we're talking about the temperature of the metal. Remember, the metal started out at 325, and now it's at roughly 79. The water started at 23 and it went up, and that makes sense. The hot metal went into the water, it raised the temperature. The cool water raised up to 79. The hot metal, it then cooled off down to 79. So everything worked out fine. Hopefully this makes your matters a little bit easier to understand with a little bit of practice. You'll have a homework problem tonight that practices this as well. So thank you very much, and we will see you on the next video. Bye-bye.